In this video, I'll be solving a perfect square problem. Suppose that n is a positive integer. If 2n plus 1 and 3n plus 1 are both perfect squares, prove that 40 is a factor of n. We have two perfect squares here, and we have that 40 is a factor of n. We need to prove this. And well, what to show is that 40 is a factor of n, but we don't know the divisibility rule for 40 and it's complicated. So we can break 40 down into 8 and 5 because 5 times 8 equals to 40. So what to show? If 8 is a factor of n and 5 is a factor of n, then the proof is complete. And now, since 2n plus 1 and 3n plus 1 are both perfect squares, we can let them equal to x squared and y squared. Let two n plus 1 equal to x squared. 3n plus 1 equal to, you can let this equal to y squared. So then, let's start with 8 is a factor of n. We want to prove this. Prove 8 is a factor of n. So to do that, we will need to use parity because to be a multiple of 8, the n has to be even first. And now, a very obvious thing is that since 2n is even, so 2n plus 1 is odd. And here we can use the property of perfect squares. Let m be a general perfect square. Let m squared be a general perfect square. Now, since m squared will be congruent to 0 or 1 or 4 mod 8, this means that any perfect square when divided by 8 will have a remainder of 0 or 1 or 4. This is an identity of perfect squares. This is a property. Now, and 2n plus 1 is odd, as we have proved. So this means that x squared equals to 2n plus 1 congruent to 1 mod 8. Because only odd perfect squares will have a remainder of 1 when divided by 8. If you have a remainder of 0 or 4, you have to be even. Because 0 and 4 and 8 are all even. So we can get that 2n congruent to 0 mod 8. So n congruent to 0 mod 4, since 2 times a multiple of 4 will be a multiple of 8. And then now we can get that 3n plus 1 is odd. 3n will be even because n is a multiple of 4. So 3n plus 1 is going to be odd. So 3n plus 1 equals to y squared congruent to congruent to 1 mod 8. So 3n congruent to 0 mod 8. So n is going to be congruent to 0 mod 8. And now we have the first part done. Let's move on to the proof 5 is a factor of n. Now, once again, we have m squared congruent to 0 or 1 or 4 mod 5. This is another property of perfect squares. Since any perfect square, when divided by 5, will have a remainder of 0 or 1 or 4. This is a property of perfect squares. Now, should we use x squared and y squared separately, or should we use them like added together? Well, you see, for this one, you have to be sensitive about this, because if you have x squared plus, okay, fine, note that this happens, so x squared plus y squared, we are doing this because like 2n plus 1 plus 3n plus 1 is equal to 5n plus 2. You have to be sensitive about these two terms because adding them together will have 5n, and 5n is a multiple of 5. So now you can get the congruence, which is congruent to 2 mod 5. And in this case, if you have x squared congruent to 0, y squared will be congruent to 2. But that doesn't work because, as shown, m squared can only be congruent to 0, 1, or 4. Same goes for 4. If x squared congruent to 4, then y squared congruent to 2. And then y squared congruent to 3. So this means that x squared has to be congruent to y squared congruent to 1. It's the only working possibility. So x squared congruent to y squared congruent to 1 mod 5. Replace these with 2n plus 1 and 3n plus 1. So 2n congruent to 3n congruent to 0, because you subtracted 1 from both sides, mod 5. So n congruent to 0 mod 5. Since 3 and 5 are co-prime, so in order to make 3n a multiple of 5, n has to be a multiple of 5. And now, since 5 and 8 are co-prime, so 40 is a factor of n. Now, a huge importantly part of this is that you have to have 5 and 8 are co-prime. Because if they're not co-prime, you can't multiply 5 and 8 together. Like an example of this would be if you wanted to prove that 12 is divisible by a number, you can prove that, if you want to prove that 8 is divisible by a number, you can prove that 2 and 4 are divisible by a number. Like here, 2 is divisible by 4, and 4 is divisible by 4. So does this mean that 8 is divisible by 4? Well, no. 8 is obviously not divisible by 4. Like 4 is smaller than 8. So you have to make sure they're co-prime. And that's how you solve this problem. Key part of this is using 40, dividing it by 8 and 5. And then using the two cases and knowing that when m squares are general perfect square, you have to notice the different remainders and what remainder you'll get when you're odd and what remainder you'll get when you're even. But luckily for us, 3n plus 1, 2n plus 1 are both odd, so there's only one case. Using that, we were able to prove that 40 is a factor of n. Thank you for watching.